The goal of the DSL variant tooling is to connect DSL models to feature models. So let's first look at a feature model. Here is a feature model expressed in pure variants. You can see that security is either authentication or encryption. There is asynchronous conferencing with either forum or microblogging and stuff like that, an optional feature video and so on. Here you can see an architecture description using a DSL. It describes interfaces, data structures, more interfaces, components, and so on. Looking at the code a little bit more closely, you can see these what we call feature clauses. These are basically Boolean expressions that refer to features in the feature model, and the semantics is that the element to which they are annotated is only present in the model if the feature is selected. Now, regarding tool integration, there is code completion to select from the features in the feature model. If you go back to the feature model and select a feature, you can see in the relations view where in the model files these features are referenced. For example, this feature security is referenced in the logic.adsl in line 34. You can double click and go there. So as you can see, this is a simple feature reference. There is only one feature. You can also use feature expressions, feature or lists, feature and lists, a collection of features ANDed together or is it together, and the expression can use and or expressions to build an arbitrarily complex definition. The tooling also includes a processor that, after models are read, it processes these feature dependencies and evaluates whether for a given variant a feature is selected or not, and if it's not selected, the element to which the feature is annotated is removed. And of course, if it's removed, it is not available to the subsequent code generation step, meaning the code generator doesn't see it and therefore doesn't generate any code. In other words, in the generated code, the open key attribute is not going to be there. And of course, you can, as you can see, annotate the feature dependency to parameters. You can annotate it to, in this case, whole interfaces, which means the interface is not going to be there if the feature audio is not selected. Let us take a very brief look at the grammar. What do you need to do to make your grammar feature aware? Well, basically the only thing you need to do is you need to add a couple of new language elements, feature clause, feature end list, and so on. You basically copy and paste them from the documentation. And then for every model element you want, or language element you want to be able to annotate with feature annotations, you just add this little bit of code, right? It basically says, in this case, an instance has all kinds of stuff, and then it has a feature dependency. And if you look, for example, at the definition of an interface, where we saw that it can be depending on a feature, then you can see that the interface contains exactly the same little bit of grammar, or let's say an operation or interaction it's called, has one of these. So you basically copy these things in, and then you also need to add a couple of extensions and checks, but it's basically a matter of a couple of minutes to copy and paste a couple of things into your various language artifacts. Finally, to process the models and remove the elements which are not selected, you run a predefined workflow, tailor pure variants, and it takes a configuration model as well as a DSL instance, a model, architecture model as we call it here, and applies it. And after running this guy, the model is available in the workflow in a customized manner, meaning the stuff that's not selected has been removed, and then you can just run any arbitrary model processor such as a generator. So to sum up, the tooling provides a way to connect arbitrary DSLs and its models to feature models, currently pure variance based, but there is an indirection. It can be adapted to any other feature management or configuration tool. And then there are workflows available to customize the models and cut them down, as we like to say, based on actual configuration models on the variant. Finally, there is also a way to customize manually written code. Basically, we have something along the lines of a C preprocessor that can remove regions of text in manually written code.